Everybody's here? Everybody here? Shall we start? Am I audible?
Yes, sir.
Okay, so shall we start now? Oh no,
Yes.
again the same problem. They have taken the host setting. Just give me 1 minute. They have again the same problem. That host one. Everyone is able to see my screen?
Yes, sir.
Others, sorry to
Yes, ma'am.
interrupt. Students,
Yes,
switch on your videos. Anushri, Nivedita, yes, you can carry on, others.
Oh,
Thank
thank
you.
you, ma'am. Okay, so now we'll be starting with chapter sets. Okay, the first chapter of mathematics, class 11. You have to start with sets. Without wasting time, what is set? You must have used this word before also, right? So what do you mean by sets?
A well-defined collection.
That's good. That's good. So what is set? Set is a well-defined collection of any object. Well-defined collection. We have to define that collection. Well-defined collection of objects. It's called sets. Okay. Right. So set can be of anything. It doesn't matter it be of mathematics or science or whatever it be. You can see anything as nature. For example, set can be a collection of the months of a year. Okay, we can make that as a set. For example, one more thing. What are the like rules? Basically, we have to see the rules. What are the rules to write a set? So what we have to represent any set by any capital letter. Rule number 1, capital letter. right? And capital letter, that is to be equated, and the set, the elements of the set should be covered inside the curly brackets. Understood? Okay. So if we write the set for a collection of months of a year, so I'll be writing it as January, February, March, April, May, June, July, August, September, October, November, and December, right? Understood? So this is a particular set. It is well defined. All of the elements you can define. All of the elements are related to one particular condition, right? None of them is out of order, right? Everyone? Everyone? Yeah. So this is particularly called a set. Next thing. Set can be anything: the collection of vowels, the collection of odd numbers, the collection of even numbers, the collection of... Give me some examples. You all? Any set you want to make?
Prime numbers.
Prime numbers, composite numbers, natural numbers, whole numbers, integers, real numbers, anything. Sets can be anything, collection of anything, but that should be well defined. And whatever is there inside the set is called elements. These are called what? Elements. So for maths, I'm not giving you any kind of notes. I'm just writing it randomly, right? Okay. If you want anything, you get it defined. You just ask me and then I'll define it. Okay. So these are elements. Understood? Whatever is there inside the set, those are elements, and those elements correspond to one particular condition for which the set has been framed. Agree? Right? So this is set. So how to describe a set? We have to set. Basically, sets can be described in two forms: roster form, and set builder form. Roster form and set builder form. These are the two ways we describe any set, we write any set. Okay. What is roster form? What is set builder? We'll do this. So you can see here, if we write something like this, where did that is? Here we list all the members of the set. Okay. Here we list, I'm just defining, then I'll explain. Here we list the property or properties satisfied by all the elements of that set. I'll not define them. I'll give you two examples and you will classify. You read these two statements by then. You will classify what shall be which one. Let's say this is 1, this is 2. Now I'm writing here. A is a set where a set of, how shall I write it? X. Set of X. Okay. Where such that X belongs to N. What is N? Everyone?
Natural numbers.
Natural number. Good. X belongs to N and X is less than 8. Another form I am writing. 1, 2, sorry. A 1, 2, 3, 4, 5, 6, 7. Which one is corresponding to which of the statements?
First one is set builder. Second one is roster form.
Everyone agree with her? Akhil?
Yes, sir.
Okay. Ritika? Dhanushri?
Yes, sir.
Everyone agree with Nivedita? Okay. So this is called roster form. Roster forms, we list all the elements, and this one is the set builder form, where we list the properties of that element instead of writing the whole elements. So instead of writing this much, what I could have written? Tell me. What could I have written? for this particular thing containing these elements? I should have written now. A is a set of X where X belongs to all of the months of the year. Understood? So that will be set builder form. Let us do some questions. Written, everyone till here? Okay. Let us do some questions. Questions are always interesting. Who all don't want questions? Nobody? I know all are talented here. But I'll know your talent only when you write this in set builder form. Or wait a minute, this will be different. Wait a minute. You write this. You write for this 1, 2, 4, 7, 14, and 28. Got the answer? No? Why, Akhil? It's easy. Think about it. What these numbers are representing. Okay, let me give you a hint. Anybody onto the answer? Near about? Then I won't give you the hint. Nivedita?
So factors of 28.
Exactly. That's good. All these are factors of 28. Now write this in set builder form. In maths, everything is easy. All of the things you have read and learned. You just have to apply them. See, there is your subconscious mind. So if you tell your subconscious mind that everything is easy, the subconscious mind will make everything easy. If you tell it that this is hard, I cannot do it. So even if you could do it, you won't be able to do it. So this is easy. A is, tell me Nivedita, then the answer.
X is such that
X such that X. What else?
Belongs
Proceed.
to n,
Belongs to N.
and X is a factor of 28.
X is a factor of 28. Good. So this is the roster form. This is the set builder form. Okay. Let us move on to the next question. More questions you want? Let us have more questions. If I write it something like 3, 6, 9, 12, 15, and 18. Now tell me. Write this in
Sir,
set builder.
X is such that X belongs to N and X is first 6 multiples of 3.
First 6 multiples of 3, but you won't be considering 3 then. 3 is not a multiple of first 6 multiples of 3, you said.
Yes, sir.
Okay, sorry. I thought you said as 6. You should not say it like this. I need a better answer. You are correct. But if anybody can place it in a very better manner. Anyone? Even you can think, Vandana. if you can write it in a better manner instead of writing that whole statement, x is the first 6 multiple of 6, 3. Instead of saying that, how can you represent this mathematically? Akhil, think about it. Think hard. Harder.
Sir, x is a multiple of 3, which is less than or equal to 18.
Considered, but I can write it like this: x is equals to 3n, isn't it?
Yes, sir.
X is equals to 3n. Where I should write 3. How should I write it? 3n. Okay. Or instead of writing all these things, I should not write about x there. Okay, I should explain it here. See here. If I'm writing like this, x such that x is equals to 3n, condition number 1. Condition number 2, where n belongs to capital N. I'm providing restrictions over n, not x. Okay. If n belongs to capital N, x will already will belong to capital N, right? One more thing, I have to put restriction on n. So n should be less than equal to 6 and greater than equal to 1. Agree or not?
Yes, sir.
This is my set filter form. So you have to write in better manner. You don't have to write the whole statement there that x is the multiples of 3 and it should be less than 18. You don't have to write it like that. You have to write it most mathematically. Are you getting my point? Okay. Let us solve more of them. Okay. F is a set of numbers like this: 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7, 7 upon 8, and 8 upon 9. Whoever answered this will get the maths champion badge today. Make it fast. Just have to think the relation. Done? Any answers?
Sir, can it be x is equal to x is such that x is equal to m by n and
M by n. And what are the restrictions over m and n?
and m is greater than or equal to 1 and less than 8, less than 9, and n is
Greater than or equal to 1
yes, sir.
and less than 9. No,
Yes, sir.
these much restrictions. You were going correctly, but little bit.
Sir, can it be like x such that x is equal to n plus 1 by, sorry, n by n plus 1?
Any restrictions? Partially correct, but restrictions should be there. In such condition, n belongs to natural numbers and n should be less than equal to 8, greater than equal to 1.
1.
This is the answer. So Nivedita gets half champion badge. I will get half of it. Okay. So till here you all have understood. you'll be able to solve the first exercise. Okay, let us move on. Okay, now we have to understand different kinds of set. What are different types of sets, right? So there are, first let me explain you, empty set is there, or let me first write it down. First one is called empty set. Okay, second one is called singleton set. Singleton set. Third one is called finite set. Fourth one is called infinite set. And then fifth one is called equal sets. Last is equivalent set. These are the different types of set. So what is empty set? So empty
Null
set contains no element. What if I say that A is a set of X where X belongs to W and X is less than 1? Sorry, X belongs to N and X is less than 1. Name the elements there.
An empty set.
null set. Sir.
Empty set. Exactly, null set. That is also called null set or void set. Null set or void set. No element is there. No element is there. I'm just writing the definition scripts because you don't need to define them in the exams. Okay. So empty set is what? No element is there. Singleton set, only one element. Only one element. What if I write A is a set of X where X belongs to W and X is less than 1? How many elements will be there?
1, sir, 0.
0. Agree, everyone? Ratika, you're not answering anything. Participate here.
Yes, it's kind of, I got confused with the roster form and set builder.
Any doubts still remaining? Do I need to
No,
explain
sir,
anything?
I got it clear.
Okay, good, good. Finite set. Finite set. Containing
X belongs to R.
finite. That is finite.
The fixed number of elements.
Oh, sorry, sir. That's for infinite.
Yeah. Containing infinite elements. So how do we define finite and infinite? Vanna said for the infinite one, A is equals to X where X belongs to R and no restrictions if I provide. So real number is from minus infinity to positive of infinity, and that is so huge that you cannot count, right? So those are called infinite sets. Agree, everyone? Good. If I ask about finite set, I can make the same set finite by writing X belongs to N, where X is where X is less than 8. How many elements will be there?
7.
7 elements will be there. Very good. So 7 elements. This is a finite set. I put the restriction there. But if I just had left it, no restrictions, X less than 8, I did not write it there. So how many
Infinite.
elements will be there? That will be infinite. Very good. Very good. Equal sets. What are equal sets? If two sets have all elements same, then they are said to be equal.
Equal sets.
Okay, two sets having all the elements same, then they are said to be what? Equal. Agree? Agree, everyone? I'll give the example later. Equivalent sets. If two sets have same number of elements, then they are said to be equivalent sets. Okay. Same number of elements, equivalent, equal number of sets.
So if same number of elements, it's not necessary to have the same elements.
Exactly. That is the difference. I'll give you the example after this. Written till here. Shall we move on?
Yes, sir.
Everyone, Akhil, Tanushri,
Yes, sir.
Nivedita, written?
Yes, sir.
Okay. Now see here, if I write a set A as 1, 2, 3, 4, and 5, and if I write set B as 2, 5, 7, 8, 1. So set A and B are equivalent but not equal. They are equivalent but not equal. For them to be equal, each and every element of A should be equal to each and every element of set B. So can I say the statement that if two sets are equal, they are equivalent, but if two sets are equivalent, they are not equal? True or false?
Yes, sir.
Agree, everyone? You'll get these statements. Good. So understanding it fast, you're good students. Okay. So this is how you can solve the second exercise now. By going it quite fast, that's good. Next, we'll be studying about subsets. Actually, I was asked to take a revision class of yours because you all have joined late, I guess. Something like that happened, right? So the main class teacher, Raghav sir, was taking the class actually. And you all missed that. No problem. You can see the recorded lectures also if you don't understand anything, but I don't think that will be like required now. I'll try to cover everything. Subset. What is subset? A set A is said to be a subset of set B. A subset of set B if every element of A is also an element of B. Okay. Now I'll explain it. First of all, how we denote it. If A is a subset of B, we'll write A is a subset of B like this. Okay. So what happens here? See, if B is there, let us say B contains 1, 2, 3, and 4. And if A contains a set of 1 and 2, so A has taken its elements from B, right? So A will be said to be a subset of B. Everyone agree? What has to be similar? The elements, any of the elements should be matching, like every element of this particular case. It should not be like all of the elements should be taken by A. It can be 2 of them, 3 of them, just 1 of them, like that. So this is said to be a subset. One more term is there, proper subset. What is proper subset? If A is a subset of B, and A is not equal to B. See, if I write A dash, I'm terming a like new term I'm using 1, 2, 3, and 4. Won't A dash B also be a subset of B? Because even this has taken the elements from B only. Doesn't matter it has taken all of them or not. Okay. So, but if in condition A is a subset of B and A is not equals to B, then it is said to be a proper subset. But it.
Sir, A
So
is
I don't
not equal
understand,
to B
sir.
as in the number of elements.
No, not the number of elements. A is not equals to equal. When do we say equal? Equal said that all the elements of B should be equals to all of the elements of A. Okay, I gave the same example. Now, if I'm writing an element A dash as 1, 2, and 3, and 4, won't this be a subset of B? This will be a subset of B. But with being the subset of B, this is equal to B also. Isn't it? This should not be the case. If this is like, if you take this A is a subset of B, but is A equal to B?
No.
Everyone? Is A equal to B?
No, sir.
No. So if this happens, this will be called a proper subset. Otherwise, if all of the elements you are copying for making the subset, so that we won't call a proper subset, that we just call a subset. Now agree everyone? Understood? Everyone? Ritika understood? Any doubt?
Sir, actually, I have a doubt. if we have a set called A and it contains A, B, and C.
Yeah.
And actually, this lesson was actually taught in my school, and they have given it as subsets of A is equal to. They have put these set brackets and an empty set, and they have written it individually.
I could not get it. Are you talking something like this? A, B, C, something like this?
Yes, sir, like this.
We will
Yes,
talk this.
sir.
We'll
Set
talk
A,
about it. We'll talk about this. We'll talk about this. The
Okay,
total number of subsets that can be framed from a particular set. How that can be framed and what can be framed. Okay. You just give me 2 minutes. We are coming on that topic. Right?
Okay, sir.
Any doubt till here? Proper subset and subset?
No,
Yes, sir.
sir.
Ritika, any doubt till here?
No, sir.
Okay, okay. Tanushri, any doubt? Akhil, any doubt?
No, sir.
No, sir.
Okay, good. Now, if we study about the properties of subset, what are the properties of subset? One, every set is a subset of itself. As we considered this is the same set. So every set, if somebody gives you this set and said, what is the subset of this particular element, this particular set? So let's say 1, 2, 3, 4 is a subset of itself. Yeah, Nivedita.
Sir, the heading for this is the properties of subset.
You can write it as the properties or theorems of subset. Anything you can say. Maybe you can
Okay.
write the properties. Yeah, or you just write some results on subsets. Some results on subsets. Okay. So first point is every set is a subset of itself. Do I need to explain this because I've already explained it? Explanation required, anyone?
No, sir.
Okay, good. Second point, empty set. Empty set is a subset of every set. Empty set is a subset of every set. And the third point, the total number of, I'll explain this, subsets of a set, of a set containing n elements is 2 to the power n. 2 to the power n. Now see here. Every set is a subset of itself that I have explained. Second point is that empty set is a subset of every set. So what is happening there is that, see, what is empty set? Empty set is nothing, right? Empty set is nothing. So can I include, if I'm writing any set as B, if I'm writing any set 1, 2, 3. So can I include a phi term also there? Isn't it? So phi is an element of every set because it is nothing, right? So whenever anybody asks you that what will be the elements of B, even in this case, this uppercase that I've written here, 1, 2, 3, and 4. So you can write the elements of B are 1, 2, 3, 4, and 5, right? You can write those elements. So phi is an element of every set. Like, so if phi is an element of every set, so can't that, like if I'm writing any set C containing no element, so that will be also a subset of here now. That will also be a subset of this B. Agree or not?
Yes, sir.
Everyone? So that's why it is said that empty set is a subset of every set. So easiest set that easiest subset that you can make from any set is the empty set. Right? Everyone, any doubt? And the third point that answers you, Ritika. If any set is containing any number of elements, and for example, here, if I'm not writing the phi element there, because phi can be written, cannot be written. That depends. That doesn't matter. If I'm writing D, 1, 2, 3, any element, 3 elements are there. So how many subsets you can make? You can make 8 combinations of subsets in case of this element D. How? 2 to the power 3, that are 8 subsets are possible. And what are those? You can write those as okay. I shall move on to the next page. Everybody written till here? Everybody written till here?
Yes, sir.
Everyone? Tanushri written?
Yes, sir. Yes, sir.
Okay. Now see, if it is D as 1, 2, and 3, and I said that there are eight subsets possible. So what you can make either the subsets of only one element, 1, 2, and 3, like this. Then you can make a combination of two elements. That's what your school has taught. Ritika, this is what they have taught now.
Yes, sir.
2 and 3, and then 1 and 3. What else you can make? You can make a combination of all of them, and then you can include the
Sir,
5
the
there.
null set won't be included.
Huh?
The null set won't be included in this.
Yeah, that's what I'm saying. 1, 2, 3. This is one element, and the last element is 5. Written. Now, last sir, we can make combinations relating to 5 also, na? You'll ask this question. Nivedita, see here. Otherwise, you won't be able to understand. I guess you're just writing there. Am I audible, Nivedita?
Yes, sir.
See here. Otherwise, you won't be able to understand this. This is very important. So how many sets we can make? We can make 8 sets. Okay. And what are those? Either I can take the individual combinations. This is a subset. This is a subset. This is a subset. Or I can take the combination of 2, any of these 2. Or I can make the combination of all of them 3. The equal set is a subset of all of them, right? And the 5. Now, can you answer me, sir? Why didn't you not like make any combination related to 5? Can anybody
Because
answer
it's
that?
not given in this set.
Pardon, Vandana.
Because it is not given in this set.
It is there. It is already there. Even if it is not given, it is already there. It is hidden. And yet it is hidden in all of these elements as 5. In all of them, it is available. So I cannot write any of them like 1 and 5. This will be same as this. Now, did you understand? Okay. So how many subsets can you make? You can make 2 to the power n subset from n elements. Got
Sir?
it, Ritika? No.
Sir, but if 1 is written as 1, 5, is it wrong?
Basically, it should not be written. 5 is just nothing. How can you give space to that? If it is written,
Okay,
no problem. But it is already there. If I'm just writing any element, let us say that I'm writing F is a subset of D and F contains 1. So it is not containing 1, it is containing 1 and 5 both. Without
sir.
defining, it is containing both. So you don't have to define that. Understood? So that's why it is hidden in all of them, and I don't have to consider that as like making the combinations. Agree? Everyone? Akhil? Good. Tanushri? Ritika, doubt over?
Yes, sir.
Good. Let us have some questions. Okay, you know this thing now. If I'm writing X belongs to A, B, and if I'm writing X belongs to A, B, and X belongs to A, B,
Yes,
I'm
sir.
giving options. X is less than A, less than B. X is less than equals to A, less than equals to greater than equal to B, and X is less than equal to B, greater than A. This is 1, 2, 3. This is A, B, C. Match them. And I want the
Sir.
answers one by one. One
Sir,
person
two-
will answer only one. 2 matches with
with
what?
B.
B. No, this is wrong.
Sir, 2 matches
Anybody
with C.
C. Okay,
Sir,
that's correct.
3 matches A.
3 matches A. And then
One
one
matches B.
Wow, what an answer, Akhil. If 2 of them are correct, then the third one will be correct now. Nice choice. He was waiting for the 2 answers. Okay. Now see here. Basically, these are called open brackets. These curved brackets are called open brackets. And the square one is called, I should not write like this. I should change the color so that you understand it. This is called open bracket and this is called closed bracket. For closed bracket, you have to consider those 2 points, right? And for open brackets, you have to leave those 2 points. Agree? Okay, I'll just ask one question and then we'll move on. Let A be a set of 1 and inside a set of 2, a set of 3 and 4 and 5. So what do you mean by this? So why didn't you not write just 2 and you wrote it inside the curly brackets? Right? You must be having that doubt. Everyone? So actually, A is not containing that element 2. A is containing a certain set that we don't know. That is containing the element 2. Okay. So if we can say that A is directly containing element 2, wrong. A is containing the set of 2, right? Got it? By writing
So
this,
that means A contains a set that a subset that is in set B.
we cannot write it directly like that. Okay, so, we cannot explain it to be subset because subset should be like if A is containing 1, 2, 3, and 4, and I want to make a subset of it. So I should make any of these elements only 1 and 2. It should not be like we should contain 1 and 2 and it can also contain 5. Then it won't be a subset of it because it is containing an extra element that is not there in the set A. So similarly here in A, even if it is containing a set of some other element, it is containing some other elements also that is not there in that set. So we cannot say directly A is a subset of that particular element. Got it? Good question.
Yes, sir.
So now see here, A is containing a set which contains the element 2. So can we say that A is directly containing that element 2? Yes or no? Can we say that A is directly containing that element 2? Yes or no? No. Should answer this. I just answered it. A is not directly containing that element 2. Okay. So here are 3 questions, 3 statements I have done based on this particular set. You have to answer true or false. So first one, does 2 is a subset of A? Yes or no?
No, sir.
Is 2 a subset of A? Everyone. I want the answers from everyone. Because I need to get that confirmation that you all have understood it or not. Vanna said no. Nivedita?
No, sir.
No. Akhil?
No, sir.
Okay. Ritika?
No, sir.
You all have understood and then you are saying no. Okay. Tanushri?
No, sir.
Okay. So you all have understood now, no doubt there
Yes, sir.
that A is not directly containing that element. A is containing a set particularly. Okay. And that is being contained that element. So can I say that this set 2 is a subset of A?
Yes, sir.
Yes,
So
sir.
now
Yes,
this
sir.
is an element. This is an element. Okay. Just 2 is not an element. This whole is an element. This whole is one element. 3 and 4 are not individual elements. So how many elements are there? 1, 2, 3, and 4 elements are there, not 5 elements. You don't have to count 5 elements there. Understood, everyone?
Yes, sir.
Okay. So this whole set is one element. So we cannot segregate them. 3 and 4 cannot be segregatable. Cannot be segregated, separated. Got it? You wherever, like, even if you have to make a subset containing that particular 3 and 4, you have to make them as one set like this. Like I can make a set B, subset B containing element 3 and 4 and 5 like this. So this is a subset proper. This is a subset of A, not proper. This is a subset of A. Oh yes, proper. It is proper because it's not equal. Okay, understood everyone? Got this concept? Tell me, this is true. Tell me this 1 and 5 belongs to A. There's a subset of A. Yes or no?
Yes, sir.
Yes, sir.
True. Good. Fourth one,
No, sir.
No, sir.
everyone? Got it? Any doubt, you just poke me out. I'll explain it to n number of times. This fifth one,
Yes, sir.
Yes, sir.
just 1 minute. Correct. Yeah. Sixth one,
No,
No,
sir.
sir.
what will be the correct statement then?
Sir, 2 should come within
So
brackets.
2 should come as a
And
separate set
four
and
should
3, 4 should come as a separate set.
Everyone agree with it? All of
Yes.
you? Great. So now you can make the third exercise also. I'm just adding on your exercises in burden, right? But for the next 2 years, you have to work a lot. That's what I'm telling you again and again. Yeah. We were there? No. On this side. Yeah. Okay. Next, we have to see operations on sets. Okay. Operations on sets. See, there are something called union of sets. Operation on sets. Tomorrow also we have a class now. Tomorrow is Sunday, and I guess tomorrow morning we have a class.
Yes, sir.
Yes, sir. 10.
Right. So tomorrow morning, what you'll be doing, you will try to make questions, because in physics I don't have I haven't taught you much. Those are just theoretical parts, so you don't have to remember them. What you do, you try to solve questions, as much questions as you can. Got it? Or tomorrow we'll be doing it, because I think I'll be completing this before time. But in sets and functions, those are two big chapters. Relation is a small chapter. Yeah. So we have time tomorrow morning, and then tomorrow, after that, next Saturday, Sunday, 2 more classes, and then I'll try to arrange 1 more class so that I can make you solve questions, because without solving questions, we don't get the confidence, isn't it? Solving questions is much required. Okay. We'll stop here itself. So what books do you follow? Tell me. What books do you have right now?
NCRT.
Anything else?
R.D. Sharma.
R.D. Sharma is a good book.
Oswald.
Pardon? Vanna?
Oswald.
Oswald. They make sample papers now. The sample papers you have to do at the end. You get R.S. Agarwal. At least. Apart from NCRT, you solve either R.D. Sharma or R.S. Agarwal. I'll recommend R.S. Agarwal first, then R.D. Sharma, because R.D. Sharma contains some questions that are quite lengthy, sometimes not required. But that is a good book. Even I used to solve in my time. I'm in NIT Jamshedpur. Okay, I cracked NEET and JEE both in 2020. My father wanted me to become a doctor. I never wanted. Okay, so I won't I'm not an example like don't follow your father. So R.S. Agarwal, you get it? You may get this in the PDF form also, in the Google or some search somewhere, you'll get this. Okay. And try to solve the first 3 exercises. Till subsets we have done. Try to solve subsets and get me the doubts in the next class.
Okay,
Want to solve one more question? If we can, let me see. write down all the possible subsets of 2, 3.
Can I tell, sir?
Go on.
Null set 2, 3.
How many you made?
4
4,
elements.
4.
actually 4 and 2, 3.
You said null set, then
2,
2,
3,
3.
2,
Hmm.
3.
everyone agree with it?
Yes, sir.
Everyone had the same solution? Good. This is correct. You may take, yeah, there are 2 elements, so 2 to the power 2, that is 4 elements, 4 subsets can be framed, and all of the 4 you need correctly. So I hope you like the session. I don't know.
Yes,
I used
sir.
to learn from my teacher, and if I don't like them, I used to like talk about them at the back end, and then everything I could say with my friends, like he was like that, he was like that. You all do the same thing now. You do for me too. Okay. Any doubts?
No, sir.
Any kind of doubt you may ask to me related to your subject, your chapters, or if you want something as consultancy about anything. Or shall we end now?
Yes, sir.
Okay, if you don't have any doubt, we'll be ending it here. And we'll be meeting tomorrow with the doubts. That time I want the doubts from your side. Bye, everyone. Good night.
Thank you, sir.
Thank you, sir.
Thank you.
Sir.